All right, so I had to pause real quick, but now we're back at 23. 23, I have an absolute value. So remember the absolute values, you always want to isolate it. So we're going to subtract 2 on both sides. See the absolute value of 5 minus x is less than or equal to 12. And then if you remember the absolute values, what we have is that this will give you different, different statements, right? If it's a less than or less than or equal to, it's an and. If it's greater than or greater than or equal to, it's an or statement. All right, and you determine this right before you split it up, right? So when the absolute value is isolated, like it is here, this is when you decide is it and or. In this case, it's and. So 5 minus x is less than or equal to 12. We're going to split it up to a positive case and a negative case. So remember the positive case, you just drop the absolute values like nothing ever happened, like it was never there. 5 minus x is less than or equal to 12. The negative case, you drop the absolute value, 5 minus x, but you have to flip the inequality and put a negative in front of the number on the other side. So it's now 5 minus x is greater than or equal to negative 12. And then from here, we're going to solve this out for x, subtract the 5. Negative x is less than or equal to 12 minus 5 is 7. Or x is greater than or equal to negative 7, right? Multiply by a negative, flip the sign. Subtract 5 here as well. Negative x is greater than or equal to negative 12 minus 5 is negative 17. Multiply by a negative, less than or equal to 17. And that's what I have, right? Multiply by a negative, you flip the sign. And this will be an and statement. Like we said before, it's going to be and because it was less than or equal to before we split it up. That's what matters. So if you have your number line, you have negative 7 to 17. I want everything greater than negative 7. Sorry, greater than or equal to negative 7. And less than or equal to 17. Right? So this is kind of like my rough draft right here. And my final answer will be where they overlap, which is right in the middle. So my answer is x is going to be greater than or equal to negative 7, less than or equal to 17. We can put this in set notation like that. That's set. A little more room. Interval will be negative 7. Sorry, that should be a bracket. Get the raise to pop up. Negative 7 to 17. They both get brackets because they're both equal to negative 7 and 17. All right, 24. Yeah, we should have room for that. 24. So what you want to do for this one is you want to isolate the absolute value just like before. It's no different than the previous problem. The only thing I need to do here is divide it by negative 3. Negative 18 divided by negative 3 is a positive 6 now. Because we multiplied by a negative or divided by a negative, you have to flip the sign. Absolute value of 2y minus 4. And this is when, well, first actually I'm going to reorganize this. I'm going to rewrite it with the absolute value first. Absolute value of 2y minus 4 is greater than 6, right? It's opening to the absolute value, so you keep it that way if you're going to reorganize it for the absolute value first. And because it's the absolute value is greater than, it's going to be an or problem, right? Remember we said before, if it's greater than, it's or. Just make sure the absolute value is on the left side. That's why I flipped it over. Okay? So just like before, make your two cases. The positive, where you just drop the absolute values like nothing happened, 6. The negative case, where you drop them, but then you have to flip the absolute value and put a negative and solve these out. So you have 2y is greater than 10, or y is greater than 5, or add the 4, 2y is less than negative 2, y is less than negative 1. Okay? From here, it's an or problem. That means you kind of just add them together. So we have 5 right here, negative 1 right there. So I want y is less than negative 1. So it's an empty circle because it's strictly less than, not equal to. And greater than 5 same logic. It's an open circle because we're not equal to 5, just greater than it. That's what my line looks like. My set notation, it's with y's, so it'll be y such that y is greater than 5 or y is less than -1. So remember, use that or notation because that's what that means or is kind of the official way to write it. And then interval, well, that's going to be from -infinity to -1 union 5 to infinity. And that's the graph. This is the set notation, and that's interval notation. All right, 2.2. So for 25, I'll write the equation of a circle with a center of 3, -1, and a radius of 4, and graph the circle. All right, so I'll pull up a graph in a bit. So write the equation of a graph. So remember, your center is your HK. So what we have here, well, the radius of 4 is r. So we have x minus 3 squared plus y plus 1 squared equals r squared, or 16. That's the equation. And if you want to graph it, do I have any graphs saved? Maybe. Let's see. I think I have something saved. Yes. Really big graph. Let's see what we can do with this. All right. So I have a center at +3, -1. So 1, 2, 3, -1 is right here. A radius of 4. What that means is from your center go up 4. From your center go right 4. Down 4. And left 4. And then try to make a circle as best as you can. Hopefully your circle looks better than mine, but that's what it looks like when you want to graph it. And of course, the center is not a point of the graph. It's just there to kind of help you get the points itself. Okay. All right. 26. So this is the hard one. Write the standard form of an equation of a circle with a diameter of -3 to 3 and -1 to -1. So remember, this is the diameter. The diameter goes through the center of the circle, right? So if I find the midpoint of these 2 points, I find the radius, or the center of the circle. Sorry, not the radius. So I use the midpoint formula. So you can average out the x's, right? -3 minus 1 divided by 2, parentheses, 3 minus 1 divided by 2. Right, this is the midpoint formula. And I'm using the midpoint formula because the midpoint of a diameter is the center of the circle. So when you do this, -3 minus 1 is -4, divided by 2 is -2. 3 minus 1 is 2, divided by 2 is just 1. So that right there is my center of the circle. So the center of your circle is the middle of the diameter, right? Because the diameter runs straight through the center of the circle. It's twice the radius. All right, so now that I have the center of the circle, or my HK, what I'm going to do is I'm going to figure out, well, what's the distance from this HK to one of these points? Because remember, these are on the outside of the circle, and this is the center. So the distance from the center to any point on the circle is the radius. So the distance I'm going to use, it's going to be the square root of -2 minus -3, so +3 squared. So I'm using -3 as my other point. And then 1 minus 3, well, plus 1 minus 3 squared. So distance is the square root. -2 plus 3 is 1 squared. 1 minus 3 is -2. -2 squared is 4. So you have 1 plus 4, or the square root of 5. So the distance from the center, the HK, to -3, 3, which is one of the points on the circle, is √5. So that tells me that, well, the radius is root 5. So that means r squared, which is what is in the actual equation, is going to be 5. So what you get is x plus 2 squared plus y minus 1 squared equals root 5 squared, which is 5. All right. And now 27, I want to write the equation of the circle in standard form, identify the radius and center. So remember for this, you want to group the x's together. So x squared minus 8x plus y squared plus 2y. And I'm going to move that negative 8 to the right side. So I'm going to add 8 to both sides. It's what I have. And now I'm going to group up the x's by themselves. We're going to add, remember, we're going to complete the square here. So I'm going to isolate the y's and the x's. And what goes in both of these blanks is b divided by 2 squared, where b is the middle term. So in this case, negative 8 divided by 2 is negative 4 squared is 16. And if you add a 16 here, you have to add a 16 on the other side. And then the next one, the b term is 2. Divide that by 2 is 1. 1 squared is 1. You put a 1 there, you got to put a 1 on the other side. All right. And then from here, these terms are always going to factor to x plus b over 2, all that squared, or y plus b over 2, all that squared. It's always going to factor in that way. So in this case, my b is negative 8. So negative 8 divided by 2 is negative 4. You have x minus 4 squared. I should put a plus there. And plus, in the y term, my b is 2. 2 divided by 2 is 1. You have y plus 1 all squared. In this case, you have 25. All right. And that's the equation of the circle in standard form. And then from here, the center is 4, negative 1. The radius is 5. Right, this is r squared, so r is 5, hk. That's what you get. All right, so let's do this. 2.3. All right, so for the table below, write the set of ordered pairs that defines the relation. Oh, what the heck? Okay. So for 8, the ordered pairs are just all the points. So in this case, you have the set of the point 3, negative 4, negative 2, 0, 5, 3, and 1, 0. The domain is just all your x's. So in this case, x will equal the set of negative 2, 3, 5, and 1. Kind of wrote it in a bad order there, but no big deal. And then the range is all the y's. So negative 4, 0, 3. I don't need to put 0 twice. I already have it in the domain. Or in the range, sorry. All right. Now determine if the relation defines y as a function of x. So remember for these, x's can not repeat. So A, the x's do not repeat, right? You have an 8, a 3, and a 5. So yes, this is a function. For B, I have a negative 3 happening twice, right? In this point, in this point. So no. For C, I kind of have 3 things happening at once. All right, that didn't work. All right, so for A, this one is not a function because by the vertical line test, it passes the line. So no. This case, it is a function because no matter where I draw a vertical line, I only go through one point. So yes. In this case, is also no for C because at that one point, only one point, I do have 2 x's repeating. That can never happen. So CC, or 29CC, I guess, is no. For D, this is a function because all these x's are going to one y. So you share the y is repeating. That's not a big deal, but the x cannot repeat. That's a function. All right. I'm going to do 30. I'm going to stop this video there. I'll finish the rest later today. So h of negative 3, we're just going to plug it in. So h of negative 3 will be 4 times negative 3 minus 3. 4 times negative 3 is negative 12 minus 3, which is negative 15. For 0, plug in 0. You have 4 times 0 minus 3. 4 times 0 is 0, minus 3 is just negative 3. For h of s, you're just going to plug in s for x. Because remember, all these problems, all you're doing is plugging in the value here in for x. So when x is negative 3, you plug it in. So you have 4s minus 3. And then 2a minus 5 will be 4 times 2a minus 5 minus 3. I guess I should write this a little nicer. 4s minus 3. So remember, you always plug stuff in parentheses, then take it out. That's why in this last one, I have 4 times 2a plus 5, which gives you 8a minus 20 minus 3, or 8a minus 23. All right, so I'm going to stop the video here. I'll finish the next, I think I have like 10, 12 more problems left. I'll finish the rest of that later. It shouldn't be a long video, but hopefully so far these videos have been helpful, guys.